This video talks about combining like terms. So as you can see, as it says, because 12x squared plus 5x squared is equivalent to 17x squared, the expressions 12x squared and 5x squared, these two expressions, are called like terms. How come? So we'll define like terms as expressions with the same variable and with the same exponent. Those would be terms that are like terms. So now if we look at things like 12x squared and 5x, these are unlike terms. How come? They have different exponents. So even though the variables are the same, the exponents are different. They are unlike terms. So take a look at this next one here. Are those two like terms? Indeed they are. Even though we have two different variables, it's really a to the first power and b to the first power. So yes, they are like terms because they have the same variable, or in this case, the same variables, and the same exponents. Those exponents are 1. Are 12x squared and 5y squared like terms? No, they're not. You see that they have the same exponents, but they have different variables, and that's no good. So think about 12x squared and 12x. Those are not like terms either, because they're missing the exponents. So we have different exponents on that. So if we go back up to the beginning for a second, notice that we said that this 12x squared plus 5x squared is equivalent to 17x squared. What we did was we used a distributive property to get that, because 12x squared plus 5x squared can be written as 12 plus 5 times x squared. And 12 plus 5 can be combined to 17. So that's where we get our 17x squared from. Pretty neat. Okay, so you've probably done some combined terms. Let's make this a little bit bigger. There we go. So if we're going to combine these like terms together, a couple different things here. First of all, what is the coefficient? What is the number that's in front of the x? So in each of these terms, I see an x. Well, the coefficient is the number that goes out there. What is the coefficient? In this case, the coefficient is 1. So think of it as being a 1 in front of all of these. You don't have to write it, and probably after this time, I won't write it either. So now if we combine some like terms together, maybe in the past, you've done things like you've underlined the like terms. So I'm going to underline these x's. So there's 8 of them total. So this combines to give me 8 x's. And then maybe you do something else underneath the constant values. So looks like I'm adding together a bunch of 2's. 1, 2, 3, 4, 5, 6, 7, 8 of them. So 8 2's make 16. So 8x plus 16 is my expression's value.